What's one type of particle? Yes. Yeah, an atomic particle. So we're just going to call that an atom. Okay, so we have the atom. An atom could look like this. An atom could look like this. An atom could look like this. Okay, basically we just, unless we're doing a detailed Bohr model, we just represent them with a circle. Okay, that's how we draw atoms. What's another type of particle? Yeah, molecule, yeah. Now, a molecule could look like this. Or it could look like this. Or it could look like this. What can you say about all of these molecules? Oh no, I'm sorry, I'm such a dummy. That's not a molecule, that's a molecule. There we go. What is true about all of those molecules? Those molecules individually are molecules of what? We'll leave that. We'll come back to it. Or we could have what do you notice about, I'll let you finish writing first. Yes. Yeah, the atoms, you have more than one atom. And what are they joined by? They're joined by chemical bonds. Now up here, what do you notice about all three of those atoms? They're all the same. And if they're all the same atoms, then we can say that is a molecule of an, what do we call it when all the atoms are the same? All the atoms are the same, that means it's an element. Or an elephant, if you prefer. Now you'll notice in the second little group, we also have more than one atom. It's joined by a chemical bond. But in this case, we have different atoms. That's a compound, yes. So if they're different atoms, then we have a compound. In the last unit, we learned about another type of particle, very similar to an atom, but not quite, just a little bit different than an atom. See if you can think of what it might have been. Alpha particle. An alpha particle is another particle. We're not going to be dealing with that too much because it's not like a common one that's used like in just regular chemicals. Okay, but good remembering that. You may have drawn Bohr models of them. Oh, it is an ion. Yes, ions are particles. And if we're not drawing the entire Bohr model, all we have to do for an ion is say, oh, I have a circle and I can put a plus sign in it. Or I can put a circle and I can put a negative in it. Or if I want to, I can have, let's say I had an alkaline earth metal. Do you guys remember alkaline earth metals are in group 2? How many valence electrons do they have? 2. So when they form an ion, how many electrons do they lose? 2. So what charge do they become? Positive 2, because you've lost 2 negative things. So you might have an ion that is 2 positive or 3 negative or whatever. Yes? So those are ions. And then finally, or actually, you might also have something here called, we have a oxygen and a hydrogen stuck together with a chemical bond. And this entire thing has a -1 charge. This particular type of ion is called a something atomic ion because it contains many atoms. Do you guys know a prefix that means many? Poly. Okay. Poly means many. These guys here, they aren't polyatomic ions, they're monatomic ions. Yeah, mono means one. There's a fourth type of particle. Oh, I suppose we should put it on our list today just so that we have all four. We won't talk about it much today. We'll talk about it more in the future. But can you imagine a positive ion just hanging out on its own in the world, doing not much of anything? Like if you'd have just a positive ion. Or what if I had a bunch of different positive ions? Would it be possible, and don't draw this part, but let's imagine that I had a bunch of positive ions and I put them all together. Does that seem likely? No, why not? What do positives do to positives? They repel, okay? They repel, they push each other away. So when we actually do have positive ions, they are always paired off with, with negative ions. And that gives us our fourth type of particle, which is called a formula unit. A positive and negative ion stuck together. Now, it doesn't have to be just one positive ion and one negative ion. What if I had a 2+ ion? How many -1 ions would I need to pair up with that? I would need 2 of them, okay? So this would also be a formula unit, okay? The overall charge is always 0. Okie dokie. I really wanted to learn how to use Bunsen burners today, but half the class is not here. So we will do that. Hopefully, maybe tomorrow people will be back. Fingers crossed. Okay. All right, so there's our formula unit, and those are our 4 types of particles. And now we are going to go back to, nope, nope, nope. There we go. Page 6. Page 6. Okay, so when last we left, we had some atoms that were bonded together to make molecules, and sometimes they are both the same element. We have hydrogen atom, and another hydrogen atom gives us a hydrogen molecule. And we say that the formula, that's what we call it, the formula for a hydrogen molecule is, we're going to have an H. Yeah, it's going to be a little 2, but it's not squared. It's not going to go up at the top. It's going to go down at the bottom. Okay, the 2 goes, it's a small 2 down at the bottom. So if you're ever looking like at H2O, sometimes on things they'll write it like this, H2O, but that is wrong. Okay, it would be, water would be H with the little 2 at the bottom, O. Okay, so anytime we write numbers of atoms, we write them small and at the bottom. Okay, since hydrogen molecule is made of 2 atoms, what does di mean? What do you guys think di means? Di means 2. So if we have it made of 2 atoms, what type of molecule could we call it? Diatomic. Do you remember with our ions, we had a many atom ion? We called that a polyatomic ion. We had a 1 atom ion. We called it a monatomic ion. Now we have a 2 atom molecule. We call it a diatomic molecule. There are, in fact, 7 elements that exist diatomic in nature. Okay, some of them are nitrogen, oxygen, chlorine. They also exist as diatomic molecules. How many atoms do they contain? 2. Excellent. Let's see if you could write the formulas for the elements nitrogen, oxygen, and chlorine. Feel free to use your periodic table. If you need a periodic table, let me know. I can get you one. Pardon me? I can zoom out. Yes, absolutely. There we go. Anyone need a periodic table? Anyone else periodic table? Okay, so we have our nitrogen, our oxygen, and our chlorine. What is the formula for nitrogen? N2. What is the formula for oxygen? O2. And what is the formula for chlorine? Cl2. Now, is that capital C, capital L, or capital C, little l? Little l, Cl2. Okay. And you'll notice I tend to write my L's like that so they don't look like I's, okay? Because I often looks like L. What is happening? Okay, now when two or more different elements, so in this case, we're going to be taking some hydrogen and some oxygen. When those elements react in a chemical reaction, the atoms do not just mix together, they become joined. What's the word we use for joined? Bonded to one another to make what kind of a thing is water? That is a compound. In a chemical reaction, the atoms in the reactants have become joined together in different ways, and this is how new compounds are formed. A compound has two or more different elements. Are we starting to get the idea of compounds versus elements? Okay. Now, these particular compounds are called covalent compounds. In covalent compounds, the atoms share their electrons. So do you remember yesterday when we looked at hydrogen and we said, oh, here's a little hydrogen atom. And there's another little hydrogen atom. So we have the red one and we have the black one. And they both have only one electron in their outer shell. How many electrons are needed to fill that shell? The first shell. 2. Are those full? No, not yet. Are they stable? Not yet. What did they do to make themselves stable? They joined together and they shared the electrons so that they each have 2. That is a covalent bond. Okay? When they share 2 electrons, that is a covalent bond. So there's 2 types of chemical bonds. One of them is covalent, which is that kind. We're going to learn about another type fairly soon. It's called ionic, and it forms when you have positive ion and a negative ion. They just stick together because positive attracts negative, and that's the bond. Okay? This one sticks together because we have the nucleus and the nucleus, which are both positive, which would repel each other, but the shared electrons stick them together. Okay? I could just fall asleep today. Like I really could. Like I was like, how am I going to teach this class? I have no idea. Anyway, so we're getting through today. I stayed up late marking Chem 11 papers. That's probably why. Okay. Should we learn how to, once we're done with this, should we learn how to use a Bunsen burner anyway?
Yeah.
Because we need a little something to do. Yeah, okay. That's why I wanted to do it today. I'm like, we've done lots of thinky stuff. We need to do some doey stuff. And the reason we need to learn to use Bunsen burners is because we've got a lab involving chemical reactions coming up. And for it, you need to use a Bunsen burner. So you need to remember how to use it and use it safely and all of those good things. Okay, but before we do that, let's take a look at these covalent compounds. Here we have oxygen. And I'm going to draw a Bohr model of oxygen. There's O. It has 2 electrons on its first shell. And its atomic number is 8, so it's got 6. 1, 2, 3, 4, 5, 6 electrons on its outer shell. How many more electrons does it need to be stable? It needs 2 more. Oh, who might have 1 electron that it could share with oxygen? Hydrogen. So we could have a hydrogen atom, right, with its 1 electron, and it could come over here and it could share. Which is great now because that hydrogen now has 2, which fills up its shell, which makes it stable. Yeah? Uh-oh, though. Is oxygen satisfied? No, what do we need? We need a second hydrogen. Yes, we do. There it goes. And that's why water is H2O and not just HO or H3O. It has to be H2O so that both the shells get filled up perfectly. And if you're doing the enriched stuff for this unit, you'll be practicing drawing these diagrams. If you're not doing the enriched stuff for this unit, you can just be like, that looks lovely. And you might have to do some of those in grade 10, okay? Okay, writing formulas. What is the formula for water? H. Where do we write the 2? At the bottom. O. That means we have 2 hydrogens. Yep. How many oxygens? 1 oxygen. So do we write a number if we need a 1? No. Carbon dioxide is made of 1 carbon and 2 oxygens. What would be the formula for carbon dioxide? CO2. How many carbons?